Hello everyone, my name is Adriano Pérez de Moraes. I'm professor at the Federal University of Santa Maria, Brazil, and today I'm here to present an example that we created in Typhoon Hill software in order to apply for a 10 for 10 competition and also to help users. So the example that we create is about power swing and distance relay operation. So basically, power systems under steady state condition operate close to their nominal frequency. A balancing between generated and consumed active and reactive power exists during steady state operation condition, but power system faults, line switching, loss of load or generators may result in a severe power flow swings, and this kind of power flow swings may cause distance relay operation. It's considered unwanted operation because it's not a fault in the line, it's an external problem, and the distance relay may operate. So we implemented this test system here. Actually, we implemented the equivalent of the system. So we're going to see an equivalent, a line, and another equivalent here. So we are going to study this specific line here, the line between bus 9 and bus 6, and we will set a distance relay for this line, and we are going to change the frequency of the system, of one of the systems, and we're going to see that the impedance apparent is going to enter in the trip zone of the relay and may result in an unwanted operation. So in the Hill software, here we have the system, the line, the equivalent, and another equivalent on this side here. So basically here we have the parameters of the lines, and I'm going to start the simulation in the Hill SCADA. Okay, and here we can see that we can set different frequencies for this system here. So it emulates external problem in the equivalent, and we're going to see that for nominal frequency, okay, the current is a nominal value, phase A current is a nominal value, and if we change the frequency, for example, for a value, for example, 63, okay, the parent impedance is gonna enter in the relay zone, and it would result in an unwanted operation. And here you can see that the current starts to oscillate as well. Well, in order to avoid this kind of situation, we have to think about an algorithm or another relay to block the distance relay. Here we have a polygonal figure, so we have to block the distance relay when we have a power swing in the system. For that, we develop an algorithm, a very simple algorithm called CODO. It's an algorithm based on mathematical morphology. So mathematical morphology is a non-linear signal transformation tool that is applicable to non-periodic transient signals, and it's very suitable for real-time application because it includes only addition, subtraction, maximum and minimum operations. So our goal is to validate if this kind of tool is real suitable for real-time applications, as for example these PhD tests. Okay, so basically there are two operations called dilation and erosion. The main function of morphological operators is to extract relevant characteristics of the signal. In this case here, the input signal is the current, and the GM is another function called structure element. I'm not go deeper in this equation because we don't have time, but we're going to use another filters called opening and close, also based on mathematical morphology. So if you apply an erosion filter in the dilation output, we are going to have an opening filter, and if you apply a dilation filter in the erosion, we are going to have a closing filter. So the difference between the open and closing filter we call CODO. So closing, open, and difference operator. So we are going to see in the simulation that this filter will implement these functions, and this filter here can block the distance relay. So simulation is running. Yeah, simulation is running. I'm going to put 60 Hz again. Okay. 60 Hz, okay. And we're going to see that the CODO output is 0, right? And here also, sorry, and here as well is 0, right? If we change the frequency to another value, for example 63, the impedance and current enters here, and the output of the code is 1. So this signal here, for example, can use to block the distance relay, and here we're going to see the output of the filter coder, right? So here we have the filters. For example, the code algorithm is very simple. It's a dilation, erosion, dilation, and the difference between both. Okay, so here we have the output of the filter CODO, and our goal is to test if this kind of filter can be used for real-time application. So I'd like to thank all my team for making it possible. So that's it. Bye bye. Thank you.